I'm Mason.
And I'm Dominique.
This is OPTI 380A.
Lab11 Detectors with Raphael.
The purpose of experiment 1 is to measure the difference in signal between a PMT and a photodiode detector. As we can see, we get a nice spectra with the PMT, but nearly nothing with the photodiode. This is because the PMT is a much more sensitive device due to the cascade effect that dictates its performance. With this, we can then find the signal-to-noise ratio of the PMT to be 5.78. Since we didn't get any signal with the photodiode, its signal-to-noise ratio would be 1.
For experiment 2, we will be comparing the time response of the photoconductor and photodetector. The photodetector has a peak-to-peak voltage of 344 millivolts, and the photodetector has a peak-to-peak of 94 volts. As you can see by the two plots, they have very different time responses. The photoconductor has a much slower response, as you can tell by the slow rise time, and the photodetector has a very fast rise time, so it's much more sensitive. When we replace the large resistor on the photodiode with a smaller resistor, we reduce the rise time. And this is pretty significant because that means that we can increase sensitivity of a detector by decreasing the resistance. When we plug the original photodetector setup into an amplifier, you can see that the peak-to-peak voltage increases, but the rise time decreases when compared to the original. So the amplifier can make your detector more sensitive. For experiment 3, we will be observing the sensitivity of the pyroconductor detector. To do this, we will be changing the frequency of this chopper here and recording the peak-to-peak voltage. Then, when we graph it into this plot, we can see that as frequency increases, the peak-to-peak value decreases. But what that really means is that at lower frequencies, the detector is able to be more accurate. When we put our hand or other body parts in front of the detector, we were not able to get any signal. This could be due to the lack of sensitivity in the photoconductor.
For part 2 of experiment 3, we're trying to find the difference between the object temperature and the image temperature of this soldering iron. To do this, we have an infrared camera pointing to our soldering iron with this mirror. From there, if we look at the resulting image, we can see that when their magnifications are the same, we get the same light output as well, which means there's no difference in temperature between the image and the actual object. When we look at this lens right here, we can see that it is opaque in the visible. However, when we put it in front of our hot soldering iron, using the infrared camera, we can see that it is transparent in the infrared. Additionally, we can see that it does act like a lens to infrared light, magnifying the object. Here I'm using a spherometer to measure the sag of this infrared lens. After doing this and using the equations given, we found the focal length of it to be approximately 50 millimeters for both the thin and thick.